friends, welcome back. In the previous videos, we've talked about using, if you're told that lines are parallel, then you can, there's angle relationships that you can find, which are supplementary or they're congruent. Now we're going to talk about the converse of that. So these are the notes that you want to take here. If you are proving lines are parallel, you must use the converse of the appropriate angle relationship. So in this case, you are told, hey, these two angles are congruent and they happen to be alternate interior angles, for example. Then you can say, hey, those lines are parallel. So we are given, so the converse of alternate exterior angles, alternate interior, and corresponding, those would be congruent. So you're given these congruent angles, or you're given consecutive exterior, consecutive interior, and you're told they're supplementary. Okay, so let's look at an example. That always helps, right? A little bit different than just words. Okay, what would X have to equal for line L and line M to be parallel? So in this case, we are not told that they are parallel. So in order for us to figure this out, if we wanted line L and M parallel, that would mean that we would have to do, we would have to do a couple of things here. We could say, using the exterior angle theorem, we could say, okay, if this plus this equals this guy right here. So what we can say is 28x plus equals, I didn't mean to say that, equals 16x plus 48. Okay, if we minus 16x from both sides, then what we've got is 12x equals 48. Divide both sides by 12, divide both sides by 12, and we have x equals 4. Good, so for this guy, we are saying, okay, if x equals 4, then the exterior angle, then that we assume that these lines are parallel. Now let's use one where we're using more of the alternate exterior, alternate interior, and those angle relationships there. Okay, so let's take a look at this first one right here. These guys, if I want to find the value of x that makes m parallel to n. So we look at that and we see, oh, they have a relationship that is alternate interior angles. And remember, alternate interior angles are congruent. So 2x plus 20 equals 3x. If I solve for x by minusing 2x from both sides, I get 20 equals x. Okay, now that I know 20 equals x, I can plug that in. If I do that over here, I get 40 plus 20, so I get 60 degrees. And then over here, I'd say 3 times 20 gives me 60 degrees. Okay, 60 degrees is congruent to 60 degrees, and they're alternate interior angles. So if x equals 20, then these guys are congruent, and if those guys are congruent, m and n have to be parallel. That's what we mean by the converse. Okay, so let's try another one. Looking at this guy, find the value of x that makes m parallel to n. Well, first we look at it and we say, okay, they have a relationship of alternate or same side or consecutive interior angles, and consecutive interior angles are supplementary. Remember, supplementary means 180 degrees. So we have so 3x minus 15 plus 150 equals 180 degrees. Okay, so if we combine these guys here, we get 3x plus 135, because it's negative 15 plus 150 gives me positive 135 equals 180. Minus 135 from both sides, we get 3x equals 45 degrees. Or 45, so many degrees. Divide both sides by 3, we get x equals 15. Okay, so let's go back and take a look at this. If x equals 15, then that means we have 45 minus 15 here, because 3 times 15 would be 45 minus 15 gives me 30 degrees. If x equals 15, that means this equals 30 and this equals 150. That means these guys are supplementary. And if these guys are supplementary, m and n have to be parallel lines. There's no way around it. That's the converse of those angle relationships. Hopefully that helps, and we'll see you next time.